Let's take a look at the inside of an output file from Metaplan. In this output, this is the ATE50 profile from that ATE50 sequence data. The database that it was used for Metaplan is shown here, so that this tells you about the version of the database. The command you use to execute Metaplan is here, so you can check and see, make sure you gave it the right files, the right input type, etc. It tells you how many reads were processed. Then we get into the clade name, NCBI tax ID, and relative abundance. So everything below this in the file is organized in that way. The first column is going to be as specific or non-specific as you can classify to. So here we have kingdom bacteria. We expect, because we're really using a bacterial reference database, that that's what we're going to be able to see and identify. And so in fact, 100% of our taxonomic identifications are bacteria. And then subsequently, everything in the file gets more and more specific. So here we have 4 classifications at the phylum level. And those should add up to 100% of the abundance, so 84 plus 8 plus 6. We're kind of in the right space of adding up to 100% here. And we get progressively more specific down through class, order, family, genus, and species. And what we usually want to do with metagenomic analysis is we want to make a figure, right? We want to make one of those stereotypical stacked bar charts that everyone has. And we don't do that with all of this data. We only do this at a specific taxonomic level. So you might see a phylum level classification, or a family level classification, or genus level classification, but you won't see that all mixed together, and we have to be able to filter that out. The cool thing about the Metaplan file format is that it's designed for you to do that without having to do anything fancy. So the K underscore underscore denotes that you have information about kingdom. C underscore underscore denotes that you have information about class. If you want to only show records that have kingdom level information but not class level information, then you would have to be able to include one of those patterns but exclude the other, right? So the way we do that is with just some standard out-of-the-box Unix commands. So this is an example where we are looking for order level information. We're going to plot our figure at the order level. So we want O underscore underscore. Telling grep to look for that in this file. Then this little doohickey here is a Unix pipe. That means take the standard output of the first command and pipe it into the second command. So use it as standard input in the second command. That's my favorite operator in the Unix language or shell language is the pipe operator, and it should be your favorite too, because we don't have to write a bunch of intermediate files to do all this stuff. We just send one command into the next. And the next command here is grep minus v. So minus v with grep is the don't want operator, the not this, right? So grep minus v, f underscore underscore means I want order, o underscore underscore to be included, and then all of these entries that I got with order included, I want to exclude the ones that also have family, f underscore underscore. And then the last thing I want to do is pass with another pipe operator the output of my second grep into the cut command, and the cut command is going to get rid of those NCBI taxonomic IDs and just give me columns 1 and 3 out of my data file. So that is going to look like this. So you can see that all of these classify down to order, and there is nothing less specific than order. So we don't have the entry anymore for the kingdom only. We just have ones that are classified at the order level, but nothing more specific than that. And that's what we wanted with that command.